In this video, we'll be going over graphs of polynomials and certain characteristics of these graphs. But before we do, if you are not here for the lesson, there is a Desmos activity titled Polynomial Graph Exploration. So when you go to the website, the student.desmos.com, and you should already be joined in your class, take a look at this activity. So it's more of like an exploration so that you could visually see how our polynomial graphs are going to look, and it kind of guides you through a couple of those characteristics that we'll be talking about in this lesson. So here are the graphs and equations of just what we call even functions. So we're going to have even and odd functions. So here in these graphs and equations, what do you notice at least about the equations? So here, the first one, you have x squared plus 4x minus 5. Here's the second equation, and here's the third equation. So what do you notice about the equation? Like, what do they all have in common? Well, I notice here that these equations, if you were to look at the highest degree, so like x squared, negative x to the fourth, and x to the sixth. Notice how that degree of the polynomial is always what? Even. So the degree of the polynomial is even. So here, remember, we go to the degree of the polynomial by the highest. So here you have 2, 4, and 6. So these equations, the degree is even. Now, what do you notice about the graphs? But the hint is we're looking at the end of the graphs. So what I mean by that is we're looking at the ends of the graphs. So I'm just going to draw arrows here because they don't really stop. They're continuing on and on. So I'm going to show the ends here. So what do you notice that these graphs have in common? Notice how both ends go in the same direction. So both ends of the graph of our even go in the same direction. Whether it's towards positive infinity or negative infinity. So like notice how here both of these arrows, right, are going up towards positive infinity because they're going on and on and on, right? They're going up and up and up. Versus here, these two arrows, our two ends here, are going down, continuing on and on towards negative infinity, but they both are. And then same thing here. Both arrows are continuing on and on and on, up and up and up towards positive infinity. That is your ends. Now we're going to talk about that as the end behavior. So here, let's also go through and we're going to label the graphs where they're increasing and decreasing. For note taking, I'll just use I and D. But notice how here again, right, we're always focusing on reading the graph from left to right. So I notice this graph here, reading it from left to right, we're going down first up to this point. So here we're decreasing, but then notice here, after that minimum point, now I'm going up. So here on that side, we are increasing. So same thing here, read it left to right. So what's happening here on this section? We are increasing. Then notice it curves down from that relative maximum and we are now decreasing. Then it goes back up to increasing and then back down to decreasing. So go ahead and try this third one and let's see. So here we are going down because we're reading it left to right, so we are decreasing. Then here, that is that minimum value. Then after that minimum, then we are now increasing. So here we're increasing. Then we're back down to decreasing, back to increasing, decreasing, and back to increasing. So if I wanted to take a look at this graph here, and we're going to identify and take a look at the amount of zeros it has. Let me just, sorry about that. We're going to look at the number of zeros it has. Sorry, I'm trying to erase here. Oh my goodness gracious. There we go. Sorry about that, guys. So here I'm just going to kind of erase this so I can take a look at and now identify the characteristics of our graph. So here we're looking at with our even functions, I'm noticing and taking a look at the number of zeros and the roots. So notice how with my zeros or my roots, remember, we are talking about where it's crossing the x-axis. So notice how it is crossing here at 1, so 1, 0, and here at -5, so -5, 0. So notice how there are just 2 zeros or 2 roots. So here at x is equal to -5 and +1. And then just like what we said, the degree here is even. So notice how both ends going up towards positive infinity. And if we even wanted to be more specific, because we do have our equation, it has a degree of 2. Now the leading coefficient, this is also something that was discussed in the Desmos, but notice how if both ends are going up towards positive infinity, then that means the leading coefficient is also positive. Then look at the equation. Notice how this is a positive x squared. Then the y-intercept. Well, the y-intercept, so where it's crossing the y-axis, is right here at -5. So that coordinate is -0, -5. So now here with number 2, again, we're looking at the number of zeros and roots. So notice how many zeros are roots? Well, how many times is the graph crossing the x-axis? 1, 2, 3, 4. So there are 4 zeros. And then if we also wanted to list them out, because this is crossing at those points, we do have at -3, 0. We have at -1, 0. We also have at 0, 0, the origin. And we also have at 2, 0. And then the degree. Again, we know the degree is even because both ends are pointing same direction. And we could also be more specific because of the equation, our degree is 4. Now, the leading coefficient, notice how both ends were going down, right, towards negative infinity. So now the leading coefficient is negative. And also look at the equation. What do you notice? That wasn't just x to the 4th, right, but negative x to the 4th. Then the y-intercept is where our graph is crossing the y-axis. Well, where is it crossing? Right here at the origin, 0, 0. Question number 3. Looking at these here, actually go ahead and pause the video. Try and do these parts and let's see what you get. And here we go. So how many zeros are there? 1, 2, 3, 4, 5, 6. There are 6 zeros. And if you wanted to, you could list all of them here. So here we start at negative. Oh, wait. So you would have to estimate that. So some of these you would have to estimate, but at least we can identify that you do have the 6 zeros. Then the degree. So again, we know here that the degree is even. And if we wanted to be more specific, we have a degree of 6 from our equation. The leading coefficient, both ends were going up. So this is a positive leading coefficient. And again, x to the 6th was a positive x to the 6th. Then the y-intercept. So again, here where it's crossing the y-axis. So when I look here, my graph is crossing here at 0, -3. So now here looking at the odd functions. Well, now what do you notice about the equations of our odd functions? Same thing, right? Look at that highest degree. What do you know about the degree? What do you notice about the degree of our two equations? They're now both odd. 3 and 5 are odd. So the degree of the polynomial is an odd value. Then what do you notice about the graphs? And again, looking at the end of the graphs. What do you now notice about the ends of the graphs of our eye? Well, I notice here this end is going towards positive infinity, right? But this end is going towards negative infinity. And here, notice how this end is going towards negative infinity, but this end is going towards positive infinity. So the even, both were going in the same direction, but now in this case, one end is going towards positive infinity, and one end is now going towards negative infinity. So it's like a 1 and 1. So then here, if I wanted to identify where the graph is increasing and decreasing, same thing, right? Reading it left to right. I notice here as I'm reading it left to right, my graph is going up, so I'm increasing. But once I reach that relative maximum, then it goes down, so decreasing. Then we're going back up, so increasing. Then at that relative, at this point here, then it curves down to decreasing. Then here, going back up to increasing on that interval. So then number 5 here, notice how we are decreasing. So I'm going down, but then here, once I get to that relative minimum, I'm going back up and increasing. Then here, from that relative maximum, we're going down and decreasing. So now if I wanted to look at the number of zeros. So again, sorry guys, my zeros, remember, right, is where the graph is crossing the x-axis. So here, my zeros, my roots, is where we're crossing the x-axis. So how many times or how many zeros, how many roots does our polynomial have? 1, 2, 3, 4, 5. So we have 5 zeros here. Then the degree we know is odd. Then based on the equation, we could be more specific, and the degree is 5. That is our highest degree. Now the leading coefficient. So here's how I show the leading coefficient if you're not given the equation. I can see here that my leading coefficient is positive because that's a positive x to the 5th. But if I were to read this left to right, Let's say I'm going to connect my two ends. If I were to go left to right and create a straight line, what do you notice? I'm going up. So that's also a way to see that I have a leading coefficient that's positive without my equation. And the y-intercept. Well, again, here, where is our graph crossing the y-axis? Right here at -1. So 0, -1. So try this one on your own. Let's see what you get. And here we go. So how many zeros are there? Well, we have 1, 2, 3 zeros. So here we have 3 roots, 3 solutions. Then we know the degree is odd, but what specifically is the degree? 3. Then the leading coefficient we know from the equation is negative. But then just to show you also, let's say you're not given the equation. Well, if I look at the ends, now notice reading it left to right, if I were to connect them left to right, notice I go now top to bottom. So that shows now that I am decreasing, so I have a leading coefficient that is negative. And last, let's see if you got that y-intercept. So the y-intercept here, where is it crossing the y-axis? Right here at -6. So 0, -6. So now let's go through, but what we're adding in is going to be the end behavior. So we've already talked about these pieces, but now we're going to bring in that end behavior. So again, practicing labeling on the graph, we're increasing and decreasing. So I'm starting here left to right. So here I'm decreasing, then increasing on this interval. Then we're going back down, decreasing, increasing, and decreasing here on this interval. How many zeros or how many times is our graph crossing the x-axis? 1, 2, 3, 4, 5. So we have 5 zeros. Now, we could also identify, because these are whole number values, so we're here crossing at -4, -3, -1, 3, and 4. Then is this even or odd? So let's see if you remember. Well, I have one end going towards positive infinity, one end going towards negative infinity. So that makes this odd when you have a 1 and 1. Then what is the y-intercept? Where is our graph crossing the y-axis? Here, at -1. So 0, -1. I'm going to jump down to the leading coefficient. So the leading coefficient, so again, here, now we're not given the equation. Well, if I connect, though, my end behaviors, right? Starting from the left, read it left to right. Notice how it's going down, decreasing. So this has a negative, and I'll write out the words here, negative leading coefficient. So now let's talk the end behavior. So with the end behavior more specifically, because we're talking about how one end is going up towards positive and one end is going down. So now here's how we're going to look at our wording. As x values approach positive infinity. So notice how our x's, right? If I go to the right, this is all my positive values. If I go to the left, if you notice, right, these are all my negative values. So as x is approaching the positive, so as x is approaching positive values, positive infinity, what direction is our graph going? Well, notice how it's going down towards negative infinity. So the y values, or f of x, so this is our function notation for y values, is going towards negative infinity. So then here, as x's are approaching negative infinity, so see how these are our negative values? So as we're going to negative infinity, now notice what direction is our graph going? Our y values are going up towards positive infinity. So here our f of x, our y values are going up towards positive infinity. So that's how you do end behavior. So let's do another one. So here, again, let's label the graph increasing and decreasing, reading it left to right. So we're decreasing, then increasing. On this interval, we are decreasing. On this interval, we are increasing. And we are actually slowly but surely still increasing, even though it's like sliding here, it looks flat. It's actually continuing on increasing. So this is still actually all increasing. So now with our zeros, our roots, how many zeros or roots do we have? 1, 2, 3. So we have 3 zeros. Then if you also wanted to list, they are whole numbers. So -3, -1, and 4. Are even, is this even or odd? We'll take a look. Notice how both of the ends here, right? We're going to focus on the end behavior. They're both going up towards positive. So they're both here going up. So this is even. Then our y-intercept. So we're looking at where it's crossing our y-axis, which is here at -120. So 0, -120. Let's jump down to the leading coefficient. Again, looking at the end behaviors, right? Notice how they're both going up towards positive infinity. So our leading coefficient is positive. And again, I'll write out the word. So this is a positive leading coefficient. Now let's take a look at the end behavior. So what's nice about when it's even, they're both going the same direction. So they're both positive infinity. But again, here just to show you why. So as x's are approaching positive infinity, so here, as our x's are going in that positive direction, right? All the way on, continue on to positive infinity. What direction is our graph going? Up towards positive infinity. So our f of x, our y values are going up towards positive infinity versus as our x values are approaching negative infinity. So as our x is, right, we're going here now, going on and on and on to negative infinity. Notice here how the graph is still going up towards positive infinity. So our y values here are continuing on up towards positive infinity. Our y values are f of x values. So go ahead and pause the video and try these two u tries, and let's see what you get. And here we go. So how many zeros are roots? 1, 2, 3. There are 3 zeros, 3 roots at -1, 2, and 4. Is this even or odd? It is even because both ends are going in the same direction. And technically, I'll jump down to my leading coefficient. If they are both going down towards negative infinity, then that means my leading coefficient here is negative. And I'll write again out the word. So negative leading coefficient. Then our y-intercept is crossing here at -4. So 0, -4. Now the end behavior, here we go. As x's are approaching positive infinity, right? As we're going to the right, your end is going down towards negative infinity. Then as our graph here is going towards negative infinity, our x's are going to the negative, our graph, the end, is also going down to negative infinity, our y values. So then here the second one. So how many zeros, how many roots? 1, 2, 3. So we have 3 zeros, 3 roots. Is this even or odd? One end is going down towards negative, but one end is going up towards positive infinity. So this is odd. Then I'm going to go ahead and jump down to the leading coefficient. Notice how if I were to connect left to right, notice how what direction are we going? Up. So this leading coefficient is positive. And again, I'll write out the word. So positive leading coefficient. Then our y-intercept. So here, looking at the graph, our graph here is crossing at +3. So 0, 3 is our y-intercept. Now let's take a look at the end behavior. So here, as our x's are approaching positive infinity, so as we're going to the right towards positive, notice how the graph is going up towards positive infinity. So our y values, f of x, are going towards positive infinity. Then as our x's are going toward the left, towards negative infinity, notice how our graph is going down to negative infinity, our y values. Now, this is a extension question, but try this one on your own. Let's see what you get. And here we go. So this graph here represents a study that was done on P of H. And the result was that you have a degree of 4, but which of the following statements is incorrect? So which statement is false? So there is a positive leading coefficient. Well, notice here, the graph, it's, if I were to, I know it's stopping here, but let's say if I were to draw arrows to continue, well, what do you notice? This, both ends here, the graph is going down towards negative infinity. So this is actually a negative leading coefficient. So the answer was A. That was our false statement. But here, just to show you, B, the degree of the polynomial is even. Well, absolutely, because not only did it tell us that the degree is 4, which is even, notice how both ends are going the same direction. So that statement is true. Our 2 pH levels, there is an absolute maximum value. So there is right here at 2 points here. They have that same value. So here, they were at the same maximum. So there are 2 of them. That statement is true. There are 2 intervals where the function is decreasing. So here, we started reading it left to right. So hold on, let me erase real quickly. So notice how here we are increasing. Then once we reached that maximum, then we went down a little bit here to decrease. Then we went back up again, increasing, and then back down to decreasing. So notice how there were 2 intervals where we were decreasing. So this statement was also true. So that's why the answer was A.